Let's continue the questions about the entropy. Predict the sign of delta S for each of the following changes. The K is changing from K solid reacting with bromine gas into KPR. Here you have changed from one solid and half mole of gas into solid. So the probability will decrease. Delta S is negative. So N2 gas plus H2 gas has changed into 2 moles of gas. Yes, 1 mole of and 3 moles, 4 moles changed into 2 moles, so the S has decreased. KPR is solid and changed into 2 ions. I'm making ions, so I'm making more dispersion, so it's increasing. And then solid changes into liquid, the temperature increased, and the dispersion has increased. The increase of randomness, so it becomes positive. For each of the following pair of substance, which substance has a greater value of S? Is it the graphite or the diamond? For the diamond has more ordered structure than the graphite, so it has less randomness and it has less entropy. The C2H5OH liquid or gas, of course, the gas has higher entropy, more disordered. CO2 solid or CO2 gas, of course, the gas is more disordered and has higher entropy. So for each of the following pairs, which substance has a greater value of S? Is it the Na2O at 0 Kelvin or He at 10 Kelvin? The He is at 10 Kelvin, so S is equal to 0 at 0 Kelvin. Again, at 0 Kelvin, the value, theoretical value of the entropy is 0, while at 10 Kelvin, the entropy, of course, will be higher than 0. 0 is the minimum value. It doesn't reach 0 except when it is at 0 Kelvin. N2O gas, 1 atmospheric 25, or He at 1 atmospheric and 25. The N2O is more complicated molecule, so this N2O will be divided into bigger parts than the He, so has higher entropy. NH3 is solid and NH3 is liquid. A liquid is more disordered than the solid, so it has higher entropy. So predict the sign of delta S and then calculate the delta S for each of the following. 2H2S plus SO2 give us S rhombic plus H2O. When you change H2S plus SO2 into S rhombic plus H2O, there are more molecules of the reactant gases because there are 3 molecules of reactant gases, but you have only 2 molecules of the products. So in this case, the delta S will be negative, it will decrease. If you want to calculate delta S is equal to the total of the delta S of the products minus delta S of the reactants from the values that will be given, you can do every one of them and don't forget to multiply by the number of moles, like 3 moles in case of S rhombic and 2 moles in case of water and 2 moles in case of H2S multiplied also in case of SO2 will be only 1, so you get the value is equal to delta S equal to minus 186 and it is negative like we said. Then SO3 changes into SO2 and O2. 2 molecules of gas changes into 3 molecules of gas, more randomness, so it will be positive value. And see also if E2O3 1 solid and 3 gas change into 2 solid and 3 gas. So the number of solids increase, so it will be the number of solids. This is 1 solid and this is 2 solids, and this 3 gases and this 3 gases. What you can see here, because number of moles of gases equal to 0, number of moles of gases equals 3 minus 3. So we can't easily predict if the delta S will be positive or negative because I can see the number has not changed of the gases. So I can just find it by the numbers, and then don't forget also the number of moles when calculating to find it as 138. Predict the sign of delta S and then calculate delta S will do the same thing exactly. Here gas and gas give us liquid, so the delta S of course will be negative. Gas and gas will give us gas and gas. I have here 2 moles and 3 moles, so 5, while here has 6, so increase, so it will be positive entropy. The 1 mole of gas give us ions and dispersion is more, so it will be the gas is much more than the ions. This randomness is much more, so the randomness increases. It decreases because it changes into ions, dissolve it and make ions, so it decreased and it becomes negative. Calculations also can prove the same. For the reaction, C2H2 plus 4F2 give us 2CF4 plus H2. I have changed 1 mole of gas and 4 moles of gas into 2 moles of gas and 1 mole of gas into 3. So delta is equal to minus 358. Use this value and data from the appendix to calculate the value of delta S for the CF4. We'll use the same equation to find the value of S for one of the molecules. Products minus reactants. For the reaction, CS2 plus 3O2 give us CO2 plus 2SO2. Delta S equal to minus 143. Use this value on data from appendix to calculate the value of S for CS2. Again, products minus reactants, and you will find the value from the calculations. It's quite common for a solid to change from one structure to another at a temperature below its melting point. For example, sulfur undergoes a phase change from the rhombic crystal to the monoclinic crystal form at temperatures above 95. Predict the signs of delta H and delta S for the process S rhombic to S monoclinic. This phase transition is spontaneous at a temperature above 95. So delta H G is equal to delta H minus T delta S. For delta G to be negative only above a certain temperature, then delta H is positive and delta is positive, as we have explained in the previous value. When you have delta G is equal to negative only above certain temperatures, from above certain temperature, like he said here in the example above 95. So this means that delta H is positive and delta S is positive. This is the only case that at higher temperature only it will be negative delta G. Which form of sulfur has more ordered crystalline structure? If you said that the delta S is positive, if you said that delta S is positive for this reaction, means that the orderedness will increase. It becomes less disordered. It becomes less entropy. So it means that the S rhombic is more ordered than S monoclinic. Two crystalline forms of white phosphorus are known. Both forms contain P4 molecules, but the molecules are packed together in different ways. P4S and alpha, P4S and bravo. Break the signs of delta H and delta S for this process only below a certain temperature, as we agreed. If it is only at low temperatures, this is the case when the sign of delta G is positive. This consists delta H minus and delta S minus. In this case only, it becomes uh, spontaneous at lower temperature. Predict which form of phosphorus has more ordered, as we have agreed that the sign of delta S is negative. So this one means it decreases in the entropy. So the P form is more ordered. This is the sign of delta S is negative, means in this direction the P form has more ordered structure. Decrease the entropy when you move from the left one to the right one. Is the order, or it becomes more ordered, and the delta S has decreased. So consider the reaction, predict the signs of delta H and delta S. This is from 2 moles of gas into 1 mole of gas. So here, what did I do? Yes, one bond is formed and the energy is released. And since energy is released, this means that the delta H is negative. And there are more reactants, molecules of gas, and more products of molecules. So S will be negative. Change it from 2 moles into 1 mole. The entropy has decreased. Would the reaction be more spontaneous at higher or low temperature? Since you said that delta S is negative, and this reaction, you said it is also exothermic because delta H has been released because you make a form. So for this reaction to be spontaneous, delta G is less than 0. So for this reaction to be spontaneous, the favorable the delta G is less than 0 at low temperature where delta H term is dominating. Hydrogen cyanide is produced industrially by the following exothermic reaction. Is a high temperature needed for thermodynamic or kinetic reasons because there are more product gas molecules. There are 8, and here there are 2 and 3, 5 and 7. So delta S will be positive. Delta N is more than 0, so delta S will be positive From the science of delta H and S, the reaction is spontaneous at all temperatures. It will cost money to heat the reaction mixture because there is no dynamic reason to do this. The purpose of elevated temperature must be increase the rate of the reaction. That's kinetic reasons. And there is difference between kinetic and thermodynamic. Kinetic means this we need it to be faster, but thermodynamically there is no need because it's already happening, spontaneously happening. We'll see these questions from 53 in the next time.